Okay, so I did just start record. So then if anyone needs to see this later, I'll put it on Schoology. We're starting on number 3 and we're just kind of going through any problems that you guys have. So how many radians are in 8.25 rotations of a wheel? This is easier than you think it's going to be. So if we have a wheel, it starts like here and then it goes all the way around, and that's one rotation. That's a full circle. How many radians are in one circle? We were going around once. That's 2 pi, right? So we want to go around to 8 and 2.5. So you can just count if you want to. That was one time. So we can go like, this is a second time, that's a third time, blah, blah, blah. Or we can think of it as just 2 pi times how many rotations we're doing, which is 8.25. And so 2 pi times 8.25, I believe, is going to be 16.5 pi. And the reason it's a 0.5 is because like a quarter of the circle goes to 1/2 pi. Awesome. All right, any other questions on number 3? Okay, where should we go next?
I have a question on C on number 1. I know yes, I think, but like I just got a different answer in the end. So
okay, so C on number 1, I'm going to come over here to where I have work. So before we can do anything for C on number 1 is we have to make sure that it's in all like decimal and not minutes, seconds. So I had to do 27 minutes times 1 degree over 60 seconds, or sorry, 60 minutes. And then I had to do 6 seconds times 1 degree divided by 3,600 seconds.
I divided it wrong. That's the problem.
Okay.
But okay, I'll do it and then I'll come back if it's still not right.
Well, if we left it as like 140.4517 pi over 180, is that wrong?
No, that's fine.
Okay.
I just thought it was so ugly because it was already a decimal. So why not just keep it as a decimal with pi? I would though like pi in the answer. So some people might be like, well, why wouldn't you go one more step and not like multiply by pi? I like pi because that reminds me it's in radians. So I don't care if you keep it as like this number over 180 and then pi, or if you make it a decimal, but I do want pi to be in your answer.
Can you zoom out? Your square's kind of covering the answer. Thank you.
All right, Ava, I'm just checking my math because I also could have done it wrong. That happens sometimes. I'm just miswrite something.
Wait, we're allowed to use our unit circle on the test, right?
So I need to look at the test really quick. Let me put it this way. If I have a question that uses the unit circle, you will be able to use it. If I don't ask a question on the unit circle, you won't use it. You don't have to memorize for this quiz, for this test.
Okay, perfect.
So how did you get a 0.78? Because that's not, like I did the same thing you did just now, or on the work, but I didn't get that.
Did you do 140 point whatever divided by 180?
No, I think I did that times pi and then divided by 180.
That's it. So because I want pi in your answer, don't multiply by pi, just do the 140 point whatever divided by 180. And that's what I want.
Okay.
All right, so we did number 3. Let's just kind of go down the page. So does anyone have any other questions on 1 or 2? Okay. What about 4? Even if you just want me to talk through 4, I'd be happy to.
Yes, could you do that, please?
So number 4, it says find all 6 trig ratios, and then it just gave you, well, let me make sure I found the problem right. Okay, so the first one says using an angle whose terminal side contains the point -3,4. We did that at the beginning of, I think, 4.3, where I said, like, here's a point, now find all the trig ratios. So sometimes we get all bent out of shape about like terminal side. The only reason you might not know those words is we just have spent, like, it's just been so cut and paste with this lesson. So you might be like, I don't know what that means. It just means go graph -3, 1, and then do your triangle from there. So that's this point right here. It would be in the second quadrant. And so my theta is always close to the origin. And so my vertical distance is 1 and my horizontal distance is -3. In order to find my hypotenuse, I had to do Pythagorean theorem. So I did -3 squared plus 1 squared equals x squared. So that's root 10. Remember, the hypotenuse is always positive. The like either of the other legs, the horizontal or the vertical one, can be negative depending on which quadrant you're in, but the hypotenuse is always going to be positive. And then once I found all those sides, then I just had to remember what my opposite, my adjacent, and my hypotenuse was.
Do we need to put theta after them?
No, I'll probably fill this in for you and just like leave blanks for this.
Okay, okay, perfect.
Mhm. All right, similarly for letter B, it's the same idea, but I actually drew the triangle for you. So for 4B, it was already drawn for you, so it was a simpler problem, I think. You just had to find the hypotenuse, and then we just had to find all the trig functions. And this one was not like on a coordinate plane like the other one was, so all of my trig functions were positive. On the other one, you had to see like what the sides were, if it was negative or if it was positive, so you had to be careful there. Okay. All right, do we need to talk about number 5?
Yes, please.
Okay. So I'm going to zoom out so you can still see 4B, but you can see 5 as well. So it said find the arc length. Remember we did the arc length formula back in 4.1. It's super simple. It's just S, which is the arc length. That's like actually what we're finding, equals theta. So the angle, and the angle must be in radians, times R, which is the radius, which we know the radius is just like from the center to the side of the circle. So I told you that it was 18 degrees and I told you that the radius was 6. So I could just fill 6 in for R, but to find theta, I had to put that into radians, and then I could multiply those two numbers together. So 18 degrees, do 18 times pi over 180, and that's just pi over 10. And then when you do pi over 10 times 6, I could just simplify it to be 3 pi over 5. If you wanted to multiply or do 3 divided by 5 and get a decimal, that would be 0.6 pi. If you rounded and did 0.6 times pi, it would be 1.884 or 0.5. I think this answer is the most exact. And so if I say exact, make sure you leave it as a fraction and with pi. But if it says like round 2, then you can round it all the way out.
Will you like give us the formula or no?
I will probably not give you the formula. It also is not worth that many points. So, but it's also not that hard to know. If it was a more intense one, I'd give it to you, but I think you should know this one. All right, are we gonna have to do number 6? Okay, I see some nodding. So I see some shaking heads, but I see some nodding. So I'm gonna do number 6. I hope we're done with 5. If you want me to zoom back out, I can, but this number 6 fits the whole screen. So this is like one that was on our most recent quiz, and a lot of us did pretty good on this. The common mistake was not putting it in the right quadrant, so then your signs were wrong. But for the most part, we did pretty well. We knew that, okay, if I was given tangent, that's opposite over adjacent. So I know that my -2 is my opposite and my 7 is my adjacent. And then you guys knew really easily how to find my missing side, whether it was the hypotenuse or just one of the other sides. We do Pythagorean theorem. And then once you have all 3 sides, you can name any of the 6 trig functions. The problem that we have is figuring out which quadrant it is. So you could draw this triangle just in like in space, however you want, but the quadrant is what tells us whether things are positive or negative. And I tell you that by giving you 2 pieces of information. So I tell you that tangent is negative, and then I told you that cosine is greater than 0. So tangent is negative. We have to remember all students take calculus. Tangent is positive in A and T, which makes it negative in S and C. All means all are positive. S means only sine is positive. T means tangent is positive, and C means cosine is positive. So personally, I have to think in terms of positive. So I'm like, okay, well, if I know it's positive in 1 and 3, then that makes it negative in the other 2 and 4. Okay, that was helpful there. Now, if it says cosine is greater than 0, that means cosine is positive. So cosine is positive where it says it, all and cosine. So if what I had shaded before, I didn't mean to erase those. Tangent being negative is true in 2 and 4, and then cosine being positive is true in 1 and 4. So the one where they overlap is 4, where I have both of my signs. So that's why I drew that, my triangle down there. Another thing, make sure you're drawing your triangle like that, like this, with like the angle down at the bottom and like with your horizontal in that corner, or the right angle in that corner. I saw some people even on the most recent quiz draw their triangle like this. And while that makes a triangle, that's not what we're doing. So make sure it's a bow tie angle. Okay, let's see, what else do I want? Let's see, since it's in quadrant.
Wait, so
Go ahead.
I was just gonna say, how did you get like those answers? But I think you're going to that.
Yeah,
I'm
that's-
gonna-
You're like 1 step ahead of me. So these answers come from, this is my angle, and it says I want sine. So sine is going to be opposite over hypotenuse. So I just did -2 over root 53. I won't take off for rationalizing, but I did it all the way across. So I just multiplied by root 53 on both top and bottom, which is how I got that. And then secant is the reverse of cosine. So we know cosine is adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. So I had to do root 53 over 7. And then that's positive because cosine is positive in this quadrant, and then sine is negative here. So that's why that's negative. All right. Any more questions on that one? All right, what about 7?
I have a question on, I didn't get the same answers as you on A, C, E, and F, so I'm confused on those.
A, C, D, and F. Okay. I bet your problem for A is that this is in radians, not in degrees. So 2.3 with no degree sign behind it means that it's in radians. So you need it to be in the radians part of your calculator.
Oh,
Mhm.
okay.
How do you know when to be in radians or degrees?
Good question. If the problem gives you degrees, then we have to be in degrees. If the problem is in radians, then we need to be in radians. So just match whatever the problem says. Now, letter A, you might have thought it was degrees because it has no pi with it. Is that what some of you guys thought? You're like, oh, there's no pi, it must be degrees. Well, there's no degree sign behind it. If there's no degree sign, that's not degrees, it's radians. So in this one, A and C and E were all radians. B and D and F were all degrees. So we're often in degrees, but like on a problem like this, you may flip back and forth a couple times. So just read what's going on.
Wait, you said the ones you circled were in degrees?
Mm-hmm. The ones I circled are degrees. The thing is though, you have to do something on B and F before you can just plug it in. Like I can't just type cosine of 12 degrees in 11 minutes. I need to make 11 minutes into a decimal and then I can just do cosine of 12 point whatever that decimal is.
Wait, but when you do the opposite, like cotangent, secant, cosecant, what do you do? The negative one?
No, good question. You have to do 1 over that number.
Oh.
So for like letter D where it says cotangent of 10 degrees, we're going to do 1 over tangent of 10. If you do the second tangent, that would be the inverse of that. That's not what we want.
What does your answer for F say? I can't tell.
Yeah, F says 3.089.
Oh,
Is that what you got?
yeah.
Okay, good.
I'm still confused how on D you go from cotangent to tangent.
Good question. So on that one, Liz, there's no cotangent button in the calculator. So the button that we do press that goes with it is tangent. So when I give you something like cotangent, cosecant, secant, though there are no buttons like that on the calculator. So for those three, we have to do 1 over their reciprocal function. So cotangent becomes 1 over tangent.
Why
Secant,
can't I just do the second of it?
the second of it happens when we don't have the angle. So if you have cosine to the negative 1, it's because you don't have the angle. So it meant that we had like cosine theta equals like 1 over 5. So it's not when you have an angle, it's when you have a ratio.
Okay.
Mhm. Okay, any more questions on these and number 7? Okay. Let's see. So number 8, that's I think Laura, what you were asking about, like, can we use our unit circle? So what I'm gonna say is I haven't looked at the test today. I've kind of had a crazy day. So if I include problems like this, then I'll say, yes, you can use your unit circle. If I like cut this from the test, then I'll say no unit circle, but I won't have expected you to memorize the unit circle. Does that make sense to everybody?
Yes,
Okay, good.
perfect.
I was confused on D, F, and E on this one because, like, I didn't see those on the unit circle.
Yeah, so these are not on the unit circle. Good point, Ava. So when I have like sine to the negative pi over 2, when we do our normal like unit circle, we go like this way around the unit circle. That's my positive angles. If we went down, that's a negative angle. And so when I'm doing sine of negative pi over 2, that means I'm going a negative way, pi over 2 units.
So I don't know where it is.
Well, how much is pi over 2? In like,
Isn't that like half of pi?
it's half a pi, good. So if I went all the way here, that's pi. So half of it would just be this line right here. So negative pi over 2 is the same thing as where 3 pi over 2 is. Mhm.
And then we would just use those same coordinates that are right there for the sine part.
Absolutely. So whatever coordinates are there, you use the sine or the cosine, whichever one that they ask you to. So negative just means we go like down and around the other way. The last two, cosine of 7 pi over 2 and then tangent of 3 pi, mean that we're going around the circle more than once. So like 7 pi over 2, all the way around once is 4 pi, or sorry, is like 2 pi, right? And that's the same thing as like 4 pi over 2. Like I did 4 halves. Here's 1/2, 2, 3, 4. Now I have to do all of 7. So this would be 5, 6, 5, 6, 7. So if I'm just going in increments of 1/2, there's 1/2, 2, 3, 4, 5, 6, 7 means I'm back here at 3 pi over 2. And then 3 pi, I have to like kind of pause at every pi. So there's 1 pi, here's 2 pi, and then 3 pi is just at the same place as my normal pi is. So that's why I wrote equals tan of pi.
Wait,
Can
how'd
you
you?
pull pies out again?
Sorry, one question. Ava, you say yours.
I said, how'd you get 4 pi over 2 again?
So think about 2 pi as being a fraction with 2 as a denominator. So like how would we get 2 to have a denominator of 2? Well, 4 divided by 2 is like the improper fraction of 2 pi.
Oh, okay. Oh, I see.
Lex, what was your question?
Can you show the 3 pies again?
Mm-hmm. So here's 1 pi. Right? Okay, sorry. Here's 2 pies. And then I have to go 1 more pi, which is back at 180. Does that make more sense? Okay. Okay. Anything else on number 8? Okay. Let's do number 9.
Miss White, I know that you're gonna be disappointed, but these graphs, literally, I look at them and my brain explodes. Like I just don't get them at all.
Yeah, me either.
Like
Me neither.
not a singular bit.
Okay, well, let's see what we can do to fix that.
Okay.
It looks like I just drew this as a reference, so I don't think this was in any reference to any problem. I think I just had it there just so I didn't have to keep looking at my sheet. So we'll come back to these. Number 9 is not quite a graph yet. So let's look at number 9 first. Were we okay on number 9 or do we need to talk about that one?
Talk.
Can we talk about it?
Yeah. So this one's a lot similar to number, I'll come back to it. Number 6, where I gave you like tan was -2/7, and I told you that cosine was something. And so I told you I kind of had to figure out which quadrant we were going to overlap in, like where is it tangent is negative and cosine is positive. Well, number 9 is even easier because I tell you what degrees we're in between. So sine is -3/4, and it says that x, or my angle, is in between 180 and 270. Well, 180 is here and 270 is here. So that means my angle is somewhere between them. So now we just draw our little triangle in the 3rd quadrant. We find our missing side. This time it's my adjacent side because I gave us opposite over hypotenuse. And then once I find that adjacent side, it looked like it asked me for all of my trig functions. So I listed sine, cosine, tangent, and then I flipped all of them for their reciprocal functions.
Why is 7 negative?
7 is negative. Great question, Lex. 7 is negative. Root 7 is negative because we're in that 3rd quadrant. So that means that we were going left on the x side, which is negative, and we went down for the y, which is also negative. So quadrant 3 tells me both x and y are negative there.
I couldn't hear what you just said about it, so could you say that one more time, please?
Yeah, so we know that root 7 is going to be negative because we're in quadrant 3. So quadrant 3 is where the x is negative and the y is negative. So We already knew that the -3 was my opposite side, but since I went left for my x's, that means that's also -2.
Before that one though,
Oh,
like you were talking about the whole problem.
why it's in the third quadrant? That part, Ava?
Yeah.
Okay. So I said this was really similar to number 6, I think, but it's even easier because I told you that we are in between our x, our angle, our theta is in between 180 and 270. So 180 we know is right there and 270 is always here. So my angle is somewhere between them, which means it's in that third quadrant.
Oh, and then you just solve it like the regular one.
We knew
Okay.
sine is opposite over hypotenuse, and so I knew I had to find adjacent. And then as I just explained, we knew the adjacent side's negative because we're in the third quadrant, so the x is negative there.
Okay.
Okay, so when you have tangent and cotangent, I don't understand why those aren't just positive since both of them are negative.
Yeah, they both should be positive. My fault. Good fix. So as Lex probably was knowing, she knows all students take calculus, so that should be where tangent is positive. That's another thing. You could maybe not even mark that your root 7 is negative, but just know that tangent should be positive and everything else should be negative. So make sure that your tangent and your cotangent are positive, unlike what I did, and then everything else can go negative. Good question. All right. Anything else on this one? All right, now for the star of the show, what we've all been waiting for, graphs.
Wait, why did we change that to positive?
Because it was wrong. Tangent should be positive in that last quadrant.
Oh,
In that third quadrant. I just.
Okay. okay.
Mhm. All right, now it's time for sketching. Okay. So first thing we got to do is we got to recognize what is my amplitude, the period, and then essentially like your new origin or your new starting point. Once we identify those things, we need to remember what the basic like function looks like, and then we have to fit it in that box. So I'll actually do this from scratch in this space right here. So it says y equals 2 sine 1/3 x minus 1. Do we have any problem with identifying adjacent or amplitude? Are we okay on amplitude?
I still kind of struggle with that too.
Okay. Amplitude is always the number in front of the trig function. So whatever number is at the very beginning is your amplitude. So that means that wherever our middle is, we're going 2 above and we're going 2 below.
Is amplitude and altitude the same thing, or was I supposed to say amplitude?
I think it's always supposed to say amplitude. Did I say altitude somewhere?
No.
If I said that, it's supposed to be amplitude. Amplitude's what we want. My fault. Technically, I think of them both as meaning like a vertical distance, so you can call them whatever you want, but that's the first thing that we see. The next thing is the period change comes from the number in front of x. So this 1/3 in front of x means that we have to do 2 pi divided by 1/3. Well, 2 pi divided by 1/3 is going to be 2 pi times 3/1. And that's 6 pi. So that means that instead of having to do my whole sine curve from 0 to 2 pi, I now have from 0 to 6 pi. So I'm going to kind of stretch it out a little bit. The next part is if there was something in parentheses with the x, like if it was x plus something or x minus something in parentheses, that would be like a horizontal shift, but there's not that in this one, thank goodness. And the -1 at the end just tells me that we're moving down 1. So instead of starting at 0, 0, we're going to start at 0, -1.
So what do you put for the horizontal shift rule?
So I'd say none. And I would probably list my new origin off this to the side as 0, -1. Okay, so 0, -1 is essentially where my new like center of the graph is. So before I do anything too crazy, I'm gonna kind of put limits on top for my amplitude and on bottom for my amplitude. So I can go up to from where I'm starting. So up to would be at +1. And put little like a little line up here. And then I can go down to from -1, which is at -3. Now, the last thing I want to do is kind of finish my barrier. I can't go any farther left than the axis than the y-axis because that's where my new origin is on. And it tells me that I have to do everything in 6 pi. So the period is 6 pi. We didn't do any horizontal shift. So I actually am just going to go from 0 to 6 pi. We'll just call it here. So I'll just kind of close my little barrier there.
So whatever the period is, that's like the end of the graph.
Mm-hmm. So we have to do an entire sine curve, just one sine curve in this time.
Thank you.
You're welcome.
So when you're doing the amplitude on the graph, is that from the origin and then you go up to and down to, or is that from 0, 0?
It is from the middle of my graph. So now since I went down 1, normally I'd be at +2 and at -2, but since I had to shift everything down 1, now I'm at +1 and -3. Does that make sense, Ava?
No.
Okay. So in a normal perfect world, my amplitude would be here. I'd be up at +2 and then down. Oh, I went too far. Up at +2, down to -2. However, my whole graph shifted down 1 unit. So I have to move everything down 1.
Oh, because of the vertical
Yeah,
shift.
because this down 1 shifted everything down.
Okay.
Okay. So now the other points we do are just going to help me make sure my graph is centered. So we know that there are 5 important points on sine and cosine. For sine, we always start in the middle of the graph and we end in the middle of the graph. So we're starting like not on the axis, but down 1. And then the middle point, so that there are 5 points, the first and the last one are like in the center of the graph. The middle one is also in the center of the graph. Now, the best way to figure that out is it's going to be directly in between 0 and 6 pi. What's half of 6 pi?
3 pi.
So the very like middle of my graph should be at 3 pi. So I'm going to go again right in the middle there. The next 2 points are exactly in between the first and the middle, and then the middle and the last. So I think it's easiest to think about, okay, well, what's half of 3 pi? You can like kind of guesstimate. You can be like, oh, it's going to be like around here somewhere because that looks like it's halfway between. But if I wanted to know exactly where it was halfway between, just like we did 1/2 of 6 pi and we got 3 pi, we can do 1/2 of 3 pi. And that would be 3 pi over 2. So this point's technically at 3 pi over 2.
When we're graphing them, do we need to say like 3 pi over 2, 3 pi?
I want it to be at least close enough if it's not marked so that I know that you know what you're doing. I
Okay.
believe I put a grid on your test. So if you just get on the grid mark, that's fine.
What numbers do you care about?
The 5 points. So there should be 5 numbers that I see on every graph.
How do we know to put, like, for the point 3 pi over 2, how do we know to put that at 1?
Good question, Liz. That's because how a sine graph goes, and I have that up here. My normal sine graph always, starts, middle, and ends right in the middle. And then the next point in between the first and the middle is going up. And then the 4th point is going down. If it's flipped, then that makes it a negative sine graph. So if it goes down first and then comes up, that's a negative sine graph.
Okay, thank you.
You're welcome.
And why aren't we touching the dotted line? Like, why aren't we going all the way down there?
I just haven't done it yet.
Oh, okay.
So I just haven't done that last point. It's whatever the exact point is between 3 and 6 pi. I don't have an easy way of finding it, but like if I've been doing intervals of like this from 0 to 3 pi over 2 is 3 pi over 2. 3 pi over 2 to 3 pi is adding another 3 pi over 2. So if I wanted to find this point, I would just do 3 pi plus 3 pi over 2. And the best way to do that is get like denominators. So 3 pi is the same thing as 6 pi over 2. So 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. And so I just, and you're right, Ava, you have to touch all sides of the dotted line. So you have to go as far left and right as we put the dotted line and as high and low as we do the line. What I've seen a lot in the past is we do like this little box beautifully, and then we don't like fill it with an entire sine graph. Like we'll do one of these guys. And like, that's not what we want. We want it to be just one sine curve in this box. So make sure that it's spread out enough to fit the entire box. All right. Do you feel a little bit better about that one?
Yes, I do. But can you go over one more time how you got the 9 pi over 2, please?
Yeah, absolutely. 9 pi over 2 is that exact middle point between 3 pi and 6 pi. So all of these points are evenly spaced out. So we found the exact middle by doing 3 pi first. So we're like, okay, if we have 0 to 6 pi, the exact middle is 3 pi. The next easiest thing I thought was to go from 0 to 3 pi. So like, what's the exact middle of that? Once we found that that was 3 pi over 2, then that means all of these points are separated by 3 pi over 2. It's like we said, plus 3 pi over 2, plus 3 pi over 2, plus 3 pi over 2 every time. And if we did 9 pi over 2 and added 3 pi over 2, we would get 6 pi. 9 pi plus 3 pi is 12 pi, and 12 pi divided by 2 is 6 pi. So it's just kind of breaking down those fractions. And once I get the interval that I'm jumping every time, then I just add that as I need to. Okay.
So you just the interval from, like, you just divide the period by 4?
Yeah.
Okay.
That's a good point. Yeah, if we had just done 6 pi divided by 4, it would have been 3 pi over 2. And that would have been our jump. It's a good idea, Brooke. All right. Okay, that was 10A. Let's look at 10B. The only thing I want to point out is 10C and D. D was just like the basic tangent graph. So like, could you recognize it? Could you do like a baby sketch of it? And then I'm not going to ask you to graph cosecant, but I did ask you to like list what happens. So like, what would the new period be? Would there be a horizontal like shift left or right or up and down vertically, or is there an amplitude? So any questions on C and D, because I think B is the harder one. Anything on C and D before I do B?
What's the Is tan the only one that has like a weird period, or did I just make that up?
No, you're right. It looks like I wrote 2 pi here. I'm not really sure why. So that one's just pi.
Is tan the only one that has just pi?
Tan and then its partner cotan.
Okay,
Mhm,
thank you.
You're welcome. But cosecant and secant both have 2 pi, so it's the same as sine and cosine. All right, so this last graph that I've got here has all of the changes. So I've got -1/2 cosine of 2 times x minus pi plus 3. And I'll graph this too, but we'll just look at the equation. Actually, let me do this. I'm just gonna white it out. No, that's probably I'm gonna mess that up. Never mind, I'm not gonna do that. I'll just draw it somewhere else. Okay. Sorry, I'm just thinking out loud to myself. You guys are just here for the ride. Okay, so the first thing we have to do is identify all the pieces. So I have my amplitude, that -1/2 affects the vertical. I like to write amplitude as a positive number and recognize that the negative makes it a flip. I won't mark you off, but if you don't flip it, you don't get full points. So make sure that you remember the negative means that it's upside down, it's flipped. The 2 in the front of the parentheses of x goes with the period. So we have to do 2 pi divided by 2, which is just pi. And then the last part is that negative pi means that we go to the right pi, and the plus 3 means we go up 3. Okay. Any questions so far? We're all okay on that? Okay. I'm just going to find some dead space over here for us to graph. So I think the first easy thing is to find our new origin so we have somewhere that we're going to base our graph around. So our new origin is right 1 up 3. So that means I'm at positive pi, positive 3. Remember that my period is just pi and my amplitude is 1/2 with a flip. So technically we can just take this out to 2 pi and go from there. That's a little close. And then up 1, 2, 3.
Wait, why is it out to 2 pi?
It goes out to 2 pi because I'm moving over pi units and then I need a pi for my period. So I at least need to go to 2 pi. You can go farther than 2 pi, but you at least need to go to 2 pi.
Can you explain that again, please?
So let's think about it this way. If I was in a normal box, if I was doing my normal origin here, with just the period and the amplitude being 1/2 and then pi, my graph would go up 1/2 a unit, down over at pi, and then it would go down another 1/2 a unit. So it would be like in this, oh God, in this little box. Are you okay with that?
Mhm.
Now I need to move that. I'm moving pi to the right. So I've got to move it pi over to the, oh shoot. Ooh, how do I not mess this up? Ooh, probably gonna mess that up. Oh, shoot. Okay. Take 2. That's as good as that's gonna get. Okay, let me move that over now. So if I move this over pi units, pretend that's exact, and then I have to move it up 3 units from here. So my new box, instead of being like around here, I now have it up in this area. I only have to go as far as 2 pi because I have to do my whole cosine in pi units, not 6 pi like we did last time, not 2 pi like normal. We have to shove it all into a small space in pi units. We have to be done by then. So that's why I knew that I have to start over here and then I have to end at 2 pi because my period, my horizontal distance is pi units. And then my amplitude is half a pi from where I was. So let's say this is the middle. I'm going to go up a half and I'm going to go down a half like there. I'm just guessing. Again, I hate not using a grid, so I'll make sure I'll give you a grid so it's easier. It just makes it all a lot neater. So in this little box we just drew, we have to fit a cosine graph, but oh, it's got to be flipped. So make sure that you have yours flipped upside down. Before I draw that, any questions on my box?
Is the top line at what's that point? Or does it stop at 3 or is that 4?
I think it's 3.5. So the middle is 3, this top is 3.5, and then this bottom is 2.5.
Are you just basing that off of the origin?
I'm basing it off of two things. I'm basing it off of my new origin, which means that we moved up 3 units. So that's why my middle is now at 3. And then my amplitude is 1/2. So I have to go 1/2 above 3 and 1/2 below 3
From your new origin.
from my new origin.
Okay.
Those are good clarifying questions. Any other clarifying questions before I put my cosine in here? All right, so cosine is flipped. So cosine normally starts and ends high. So when we flip it, it starts and ends low. And its most middle point is going to be the highest point. Now, if we come down to our graph, what's the middle point between pi and then 2 pi?
3 pi over 2.
Good, 3 pi over 2. So you have an entire pi that we have to do this cosine. So I have to go halfway in between it. So I'm essentially going 1/2 of a pi from pi, or minusing 1/2 of a pi from 2 pi, which is how we get to 3 pi over 2. The points in the middle are, or the points between the first and the middle are in the direct center of the graph. So if my center is at 3, they're at 3. They're on like the horizontal line of 3. And then on the x point, they're exactly halfway between pi and 3 pi over 2. So what's exactly half between like 1 whole pi and 3.5 pies? That's kind of a poor question, but
Is it 2 pi? Oh, wait, no, it's not.
not 2 pi. We're going to times by 1/2 if you think about it. So I've got like 3 pi over 2 times 1/2 is going to be 3 pi over 4. If you want to think about how Brooke thought about it earlier, she was like, okay, well, if it's pi is my period, I'm dividing that by 4, then that means each of these increments are going to be pi over 4s. So this is technically 3 pi over 4. Yep. And then add another pi over 4. This will be, I think, 5 pi over 4. No,
Wait, so you do 3 pi over 2 times what?
1/2.
Okay, multiply it by 1/2.
Wait, but that's not 3 pi over 4. What did I mess up?
Is it 3 pi over 2 divided by 1/2 or multiplied by? I feel like an idiot right now.
It would be multiplied by, but my mistake, what I'm thinking in my head right now is if I was going from like 0 to 3 pi over 2, half of that would be at 3/4 pi. So what I think is probably easier is to think, okay, I'm in between a whole pi and a half a pi. So what's halfway in between that? It's a 1/4. So I'm going to add a 1/4 each time. So 1 pi plus a 1/4 is going to be 5 pi over 4. And then it might even be easier to go backwards from the last one. So 2 pi minus pi over 4. 2 pi in terms of force would be 8 pi over 4 minus 1 pi, which is 7 pi over 4.
Miss White, I'm so lost.
How are you on the actual graph part? Are you better on building the box and drawing the cosine?
Yes, I know the shape of the graph. I know that whole stuff, but the numbers itself,
It's this.
I just have no idea how you just got 5 pi over 4.
Yeah, me too.
I was just like, doing it on my own and also trying to watch. And for some reason, it just did not correlate whatsoever.
Are you okay with the 3 pi over 2?
Yes.
Okay, that's somewhere. What we're essentially doing is now exactly half between pi and then 3 pi over 2. You can even think of it like on our unit circle. So if pi is here and 3 pi over 2 is here, exactly half of that is the pi over 4 in that region. So I have to think of it as, okay, I'm essentially going from pi to 2 pi, and I'm cutting it into like the 4 pieces. So I've got a point here, I've got a point here, I've got a point here, a point there, and then at 2 pi. So we found pi, 2 pi, and 3 pi over 2 pretty easily. The ones that we struggle with are the ones right in between it. So right in between pi and 3 pi over 2, that's going to be a pi over 4. But it's not just 1 pi over 4. I have to add pi over 4 to pi. So 1 whole pi plus a fourth, 1 plus a fourth is going to be 5 pi over 4. Plus pi over 4, plus pi over 4, plus pi over 4, plus pi over 4. Now to find that very fourth point, you can do 3 pi over 2 plus pi over 4, but that would require more like denominator changes than I want. So I decided to go backwards because I thought that would make more sense in my head. So I did, okay, well, if I don't want to add to already an ugly fraction, what if I did 2 pi minus pi over 4? And I can rewrite 2 pi as an improper fraction. 8 pi divided by 4, 8 divided by 4 is 2. So that's the same thing as 2 pi. And I can do easily 8 divided by 1 is 7 pi over 4. Make a little bit more sense? Yeah. I don't know if I've said this to you guys before, but sometimes you just have to like take the L and you're like, you know what? I know so many other things. I've got a lot. If I can't label this, I'm just going to take the 1 or 2 points off it is. I get everything else right. I did my amplitude. I did the correct period. I did the right curve. There's only so many points this problem can be worth.
Yeah, I'm just gonna, you're right, I'm gonna take the L on that one.
Yeah, and that's okay. And that's sometimes part of being a good test taker and a student, to be like, okay, I just got to know when it's done. Like I may never know this. And you know what? You're going to live a good life. You're going to be okay. I don't know if people say that enough, but you're going to make it even if you can't label this axis. You're going to be okay. So if you know everything else, then maybe see how much you can guess your way through on the test. Maybe it'll be a lot easier. Maybe this was a harder problem than what I'm going to give you tomorrow. So just be like, I did the best I can. I may never learn this. That's going to be okay.
Are we still going to be doing like daily quizzes for our next unit?
So the next, I think at least into the beginning of chapter 5. So for the next.
Oh yeah, we're not even done with this. I forgot.
He's like, we're not even done with this unit. This one will go a little bit quicker. So we only have like a couple more days of new lessons. With this, I just thought it was a lot to jam pack in one test. So that's why I split it into 2.
Miss White,
What's up?
what did you do to get the 3 pi over 2 again? The middle?
The middle one, I knew that I had pi and then 2 pi. So I wanted to find the exact middle of that. So exactly between like 1 and 2 is like 1.5.
Yeah, but where does the 3 come from?
Well, it's not just pi over 2 because I'm not starting at 0, I'm starting at pi. So if I'm starting at 1, going to 2, exactly in the middle isn't 1/2. It's going to be 3/2. Because you have to think of it like 1 plus 1/2.
Okay.
All right.
Can we do number 11?
Are we all good on number 10? Or as good as we're going to be? Also recognize all of the problems that are on here. If you're like, the graphs are really tough, I only made you do 2 graphs on here. Your test out of 50 will not be 40 points graph. Like, think about the percentage of everything else on the test. There are so many other things that I need you to know that I'm not going to have a billion points on the graphs. There'll be some points, but not 50,000 million quadrillion. So take some comfort in that. Okay, so number 11 says find the arc length. So this is the formula that we did back on number 6. Number 5. This is a lot like number 5. So arc length is S equals theta r. S is my arc length. R is my radius. And then theta is my angle in terms of radians. I believe I told you that theta was 100 and r was 6. So the only thing we had to do was make my degrees into radians and then multiply that radians times the radius.
That makes sense. I don't know why I was confused on that.
It's okay. We didn't do a ton of that either. So just know how to do it for 1 or 2, but it's not meant to be too hard. So don't get too confused on that.
I accidentally just blanked out during that. Could you do it one more time? I'm sorry.
So the arc length formula is the S equals theta r. S is your actual arc length. So if I say find arc length, then you're finding your S. Theta is your angle in terms of radians. So if I give you degrees, you need to turn it into radians before you actually solve the problem. And then R is your radius. And I will give you the radius, or I'll give you the diameter, and then you can divide by 2. So we just have to like remember those keywords we know about circles. So all we had to do was make the degree into radians, and then I just multiplied 5 pi over 9 times 6, and I simplified. All right. What about 12?
Yeah, can you do that?
Yeah. So all of these are different problems. So like letter A is its own problem. It says in quadrant 2, sine is 3 over 4. In quadrant 2, so I'm in the second quadrant, sine is 3 over 4, find cosine. So I just drew my little triangle. I labeled it opposite is 3, hypotenuse is 4. We had to find adjacent using Pythagorean theorem. And then cosine is opposite over hypotenuse. So we just took the pieces that we had and we made our ratio.
So those problems are kind of like number 4.
And
Okay.
number like 6 and 9. So number 4, 1 and A and B, and number 6 and number 9. So this is one where you look at the study guide and you're like, look how many problems like this Miss White has made us do. Like draw a triangle in a quadrant, find the missing side, use the trig functions, all that stuff. Like these are good problems that like we should probably know how to do. There were a lot of practice ones on the study guide, so we should know how to do these. The only thing that's confusing usually on this one is that like we get all bent out of shape. Once we did number A, like mark it off, throw it away, draw a whole new graph. Letter B is different. So letter B now is quadrant 1. So I draw my triangle in quadrant 1. My cosine is adjacent over hypotenuse. So I label 5 and 9. And then I use Pythagorean theorem to find the missing side.
You're also just wording them like all differently, but it's all the same thing.
Yes. And that's the other thing is none of them are that hard, but they're all a little bit differently worded. So you need to be able to like put it onto a triangle like this. And then you're like, oh, I know how to solve that. It's a good point, Ava. I'll just have something a little bit off. If we can simplify the radicals, we will, but like root 7, I couldn't simplify, and root 56, I also can't simplify, I don't think. If I could, I guess I just got lazy, so. Here's C and D as well for number 12. Same idea. Quadrant, trig function, find the missing side, find the missing trig function.
For 13, just really fast, I think these are pretty easy. Isn't it just subtracting 360 and adding 360?
Mm-hmm. We went
Okay.
like above and beyond last year and did something more, so you don't have to do that 720 or the radians. Remember that 360 in terms of radians is your 2 pi. So you could either convert pi over 7 into degrees, or you can just add 2 pi or minus 2 pi.
Okay, awesome.
Yep, those are meant to be kind of gimme points. Like you should see those and be like, yes, I just add or minus 360. Easy. All right, we all good on number 12? Okay, I see some nods and some thumbs. Laura just asked about 13, so we should be good there. Number 14 is actually simpler than you might have thought it was. So this is a lot like number 6 or 9 one we just did, where you had to figure out what quadrant it was, and then you drew your triangle in that, and then you found all the pieces. This is just simply like, which quadrant is it in? So where is sine negative but cosine is positive? That's only quadrant 4.
Oh, I was doing 12 and I missed 13. Could
Okay.
you talk about 13B?
I did very briefly. So for 13b, remember that in radians, the same thing as adding or subtracting 360 is adding or subtracting 2 pi. So that's just getting like denominators, adding and subtracting. I also showed that you could have converted pi over 7 into a degree, and then you could add and subtract 360 from that. So that is also an option.
For 14, could you go over, like, again, the different, like, sine is positive in these ones and you know what I mean?
Yep. So all students take calculus. So that's our little easy mnemonic to remember these. A means all trig functions are positive. So all of them are positive there. Everything, all students take calculus is all in terms of the positivity. Nothing is negative, it's all positive. S means only sine is positive. T means only tangent is positive, and then all the other ones are negative. And then C means just cosine is positive. So for me personally, I would think, okay, cosine is greater than 0. That means it's positive. So cosine is positive where they're all positive and where cosine is positive. Sine is less than 0 means that it's negative. I have a hard time with the negative one, so I'm like, okay, well, where is it positive? The other quadrants where it's not positive is where it's negative. So if I'm thinking about sine being positive, it's in A and S, but I don't want those. I want the opposite of positive. So I want 3 and 4. So I use the idea of sine being positive to say, okay, where is it not true? So that means where sine is negative is in 3 and 4, and cosine is positive is in 1 and 4. And so they overlap in the 4th quadrant. All right, cool. Good. All right. Just have one problem left, 15. What can I talk about on 15?
Can you just do it and like do it with us, please?
Totally.
Thank you.
You're welcome. So we actually, you might have blacked this out of your memory, but we did problems like this back in geometry. So this includes Pythagorean theorem. It includes the sum of the interior angles of a triangle, and it includes trig functions. So looking at what I have in this one on letter A, I gave you this angle is 59. I gave you side little b or side AC is 5. And then I also gave you that angle C is 90. So I gave you 3 pieces of information. You can find the other 3 pieces of information. And there's a couple different ways you can do this. So if you thought of something different and still got the right answer, I'm sure you're fine. The easiest thing is if I give you two of the angles, the third angle is super easy to find. The sum of all of the angles inside a triangle should be 180. If one of them is already 90, then that means that angle A and angle B must add up to 90 as well, because 90 plus 90 equals 180. So if you'll remember back in geometry, we would do like 59 plus 90 plus X equals 180, and then we could find X. Here, we just can remember that, and it's a simple 90 minus 59 is equal to this missing angle. We remember that? Are we good on that? Okay. The next thing is you can't do Pythagorean theorem until you have at least two sides. So you need another side before we do Pythagorean theorem. So now I've got all my angles. I have to find one of the sides. You can find any side you want. What I did is I found this one here. You could have found the other one first if you would have liked. It does not matter to me, but you have to pick one of them. I picked this side. I used the angle that I had. I knew that this side was my opposite side and that 5 was the adjacent side. So which trig function is that? Tangent. Tangent of 59 equals x over 5. And then we can plug that in the calculator and solve. You could have also done the exact same angle, but instead of doing the opposite side, you could have done the hypotenuse. And then we would have just done cosine of 59 equals a over h. You could have even used the new angle we just found. You could have done 31 and done sine 5 over hypotenuse, or tangent of 31 equals 5 over x. You could have done any trig function from any angle. I just chose, let me put it this way. When we're finding all of these pieces, I like to use what they already gave me as long as I can, because if I messed up, like let's say I made a dumb mistake finding angle B, and then I use that to find like little a, then I might mess up my whole problem, as opposed to if I use what I know is true, like they gave us 59, so I know that's a fact. If I use that in my trig function, then it makes it a little bit easier. Once I found that missing side right here, this little a, then I use Pythagorean theorem. So I said 5 squared plus 8.32 squared equals c squared. Squared them, add them up, square rooted, etc.
What do the little letters stand for, though?
Good question. I guess we did not talk about this a lot this year, but we did back in geometry, and I just forgot kind of all the things we have or haven't done. The little letter is referencing the side it's across. So like if A is here, the opposite side is little a. If C is here, then the opposite side is little c. If B is here, the opposite side is little b. You also, if you're labeling it yourself, you can like cross these out if I give them to you, and you can write, okay, AC is this side right here. You can call it the two big letters that are the points. That's fine as well. Any more questions on this one? Let's go look at the last one, shall we? In this one, it looks like I did very similar. I gave you an angle again. I gave you angle B, and I gave you angle C, and then I gave you the side across from big B or little b. Those are the things I gave you. So again, I thought the easiest thing to find was the missing angle. So I did 90 minus 50 to find this missing angle right here was 40. And then again, to find the other sides, there are two sides. You can do whichever one you want, however you want. It looks like I chose to do sine of 50 equals 4.6 over c, which is the hypotenuse. You could have used x, could have used h. But I also could have done tangent of 50 equals 4.6 over like x, which would have been this side over here. Or I could have even used that x and done cosine of 50 equals x over 4.6. So as long as you have a method to your madness, as long as you use the correct trig function with the correct ratio. So if 50 is my angle and I'm doing sine and I do opposite over hypotenuse, I don't care which one you use. But that will depend on your next answer. So just make sure you're filling in accordingly. So like I found the hypotenuse. So like when I did Pythagorean theorem, I needed to make sure the hypotenuse was like on the c squared side by itself. If you did either of these tans or cosines, you would have found this missing side and it would have gone on the left side with the 4.6 squared. Does that make sense? So just kind of fill in as you know that it goes.
For the little letter ones, how do you know which one to solve for first?
Good question. There's no right or wrong answer, so you can solve for whichever one you want first.
Okay.
So it looks like I did an example where I found like one of the legs first, and then in this one I found the hypotenuse first, and then that's a different Pythagorean theorem. All right. Any more questions on B? Any more questions on the study guide in general? Anything we gloss over or you want to talk about again? No? All right.
On C of 10,
Mhm.
for the period one, I put just pi because it was like 2 pi over 2, and then I just crossed out the 2's.
Mhm. It looks like I just showed you what my work was, because if I just wrote pi, people might have been confused. So yeah, you could have crossed out pi. That's totally fine.
Yeah.
Yeah.
I have another Zoom, so
Oh, yeah.
sadly. So I just want to say thank you so much, and I'll see you tomorrow.
Yeah. I'm here to stick around. So if anybody has more questions, you're welcome to stay. If you have to go, or if you're just like, I'm so over this, you're welcome to go too. So yeah.
Thank you.
Bye, guys.
Thank you.
Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you.
I have a question.
Absolutely, Mike.
Like, are there any like big topics that weren't on the study guide that will be on the test?
Good question. No, I tried to get every problem that I want. I don't want the test to be a surprise.
Okay, so I mean, we don't need to like go out of our study guide to look for concepts.
I don't think so. You can do like a quick glance over of like what the homework problems were, but I tried to mimic anything that we like quizzed over or were in the homework that I thought were important problems. I tried to put them in here. So you shouldn't have to go search and find.
All right, thank you.
Yeah, you're welcome.
Can you do how you found the ones on 8 that I asked about earlier that were on the unit circle?
Yeah. Let's go over those again. Okay. So the ones on the unit circle are just like our normal positive angles, right? So we've got pi over 2, we've got pi, we have 3 pi over 2, and then we've got 2 pi. And that's if we just go around the circle like normal, right?
Yeah.
Okay. Letter D has a negative angle. So that means instead of going like up and around like we normally do, we're going to go down and underneath the other way. We're still traveling like pi over 2 distance, but we're just traveling in the other direction, pi over 2. In the positive direction, we know that that's just our 90-degree angle. So we just go 90 degrees and we've hit pi over 2, right?
Yeah.
The same idea as if we go negative. I'm just going down this way to pi over 2.
Okay.
So when I go the negative direction, that makes this negative pi over 2. It makes this negative pi, which is nice because that's exactly what it is in the positive direction. It makes my pi over 2 be negative 3 pi over 2. And then we come back to negative 2 pi.
Because is it just because you're going over 3 halves?
It's because we're going down in this direction as opposed to coming up in the positive direction.
Yeah, but like when you're going in the negative direction and you're like going, like the first one would be like, yeah, I see what it is now.
Yeah, so this one is only like 90 degrees. This one is 180. This one would be like equivalent of going 1, 2, 3 pi over 2s.
Yeah.
Mhm.
Okay.
Yeah, so that's the negative direction. The other two are like more positive. They're like bigger than we're used to. So we only label the unit circle one time. We just do like our normal one time around, call it a day. But we could keep spinning around and around and around and around and around and around forever if we wanted to. Each increment is still the same. So every time I go 90 degrees, it's still a pi over 2. If I'm going 7 pi over 2s, it means I need to go 7 pi over 2 rounds around the circle.
Mm-hmm.
So this is just 1 pi over 2. This one's a second pi over 2. 3 pi over 2, 4 pi over 2. So normally I'd be back at the beginning because I've done 4 half of pies.
Mm-hmm.
But we're going to keep going to get to 7. So this is going to be 5 pi over 2, 6 pi over 2, and that one's 7 pi over 2.
Okay.
You can even think of it as like, okay, let's minus off like the 360 or the 2 pi until we get to where we want. So 7 pi over 2 we know is bigger than 2 pi. So if you do, okay, let me minus 2 pi from that. Well, 2 pi, like we did a minute ago, is the same thing as 4 pi over 2. So if I go around one time all the way, then I still have to go 3 more pi over 2.
Okay.
Does that help or hurt?
Yeah, that helps more. And then also on D for number 10, the tan one,
Mhm.
is that just like we have to memorize those graphs?
Let's put it this way. I don't remember how much of it I put on the test, but I want you to be able to tell me the difference. Like if I showed you graphs, like which one's tangent, which one's cotangent.
Oh, so we wouldn't have to draw it?
No.
Because I can do it, like I know which one is which, but like if I saw it, but I just don't know if I could like do it myself.
If you could identify it, that's what I want to see.
Okay. Then that's cool. And I think that's all my questions. It's just a lot to remember.
Yeah. I think you know a lot more than you think that you do though.
The cosine stuff is easy, like identifying that, like solving them, and then the bow tie ones are pretty easy. It's just like, oh, I think I'll be fine. I hope I'll be fine.
Yeah, I think you'll be fine. I'll be around tomorrow morning too if you want to stop by for any other questions.
Okay, I think. Wait, what period is it tomorrow that we have this class?
I think it's a day 5, so it's the second to last period of the day.
Oh, okay.
Alpha, D, E, F. That's you guys, and then G.
Okay, cool. Thank you.
You're welcome. See you tomorrow, Ava.
Bye.
Bye. All right.